Hi Hires, problem solving question on experimental design. This is the 2017 past paper from SQA and question 9. Okay, so we have a catalase experiment. It's an enzyme that breaks down hydrogen peroxide into oxygen and water. Assuming we all still remember HP cow. We have paper discs soaked in catalase. They sink down in hydrogen peroxide and then they rise to the surface as the oxygen is produced. Time taken can be linked to catalase activity. Okay, we've got the aim of the experiment was set up to investigate the effect of copper sulfate on catalase activity. And then you've got a setup with 10 centimeters cubed of hydrogen peroxide and 5 centimeters cubed of the copper sulfate. And then they put a paper disc in the bottom and then they time how long for it to come back up. Not in the bottom, you put it at the top and it sinks down. Okay, here's our results. Concentration of the copper sulfate versus the time taken for the paper disc to rise. So just to be very, very clear about this is faster than that. Okay, this only took 8 seconds for the paper disc to rise back up, so for the oxygen bubbles to be enough to lift it. This one, however, took 20 seconds. So we've got a higher activity at this end than we do at the bottom end. So just be careful about that. Name the independent variable in this experiment. Okay, the independent variable is the thing that you change. The thing that we changed was the copper sulfate concentration. A suitable control. Okay, we are looking at the effect of copper sulfate concentrations. What we want to do is remove the copper sulfate. Now, for it to be a suitable control, you can remove the copper sulfate, that's great, but just remember you can't change the volume here because otherwise it would be quicker for it to move up because it would only be 10 centimeters cubed rather than 15. So what you should do is replace the copper sulfate with distilled water. Suggest how the temperature of the tubes could be kept constant. Well, this is just a straight kind of knowledge point for you guys. You would expect a water bath. Okay, so you would set a water bath at the correct temperature and then you would put the tubes in the water bath. Give a feature of the experiment which may make the results unreliable. Okay, so R and R repeats for reliability. Well, the problem here is they only did it with one disc, so there is no repeat at each concentration. So that's it. And then you're asked for a line graph. Okay, so 2 points again. So we're looking for 1 point for your axes and your scales, and then 1 point for your plot. So we're looking for concentration of the copper sulfate and the time taken. So what you changed goes across the bottom, nappy rule. Concentration of copper sulfate in moles per litre, the entire thing written down here. And what you measured goes up the side. Time taken for paper disc to rise in seconds. The entire thing put up the side. Don't miss anything off, just write down everything. Okay, so our copper sulfate solution goes from 0.2 to 1, so I think we're going to start at 0, and that'll be 0.1, 0.2, 0.3. Nicely fitting in. Nice enough scale as well. Okay, going up the side for our paper disc to rise. Again, reasonable to start at 0. You could start at 4 or 5 maybe. So what we're going up in 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I would actually probably prefer you to start it at a lower point, but it's okay because although this bit here is not going to be part of the graph, all of this is, and that is more than 50% of the scale. Okay, so having got your scales in and written it very neatly, you then have to plot the points. The points must be exactly on the crosshairs or within or between them if it is supposed to be. Which I don't think any of these, all of these fall exactly on points. So you're okay. Oh no, they don't. Yeah, your odds here. So 15 is going to have to be given between the 2 points there to get it bang on. Okay. Calculate the percentage increase in the time taken for the paper disc to rise when the copper sulfate concentration increased from 0.2 to 1. Okay, so we are looking for percentage change. So percentage change is change divided by start times by 100. Okay, so we are going from 0.1 to 0.2 to 1, so we started at 8 and we went to 20, so it has gone up by 12. Okay, so our change is 12, our start was 8. Okay, so 1.5. There we go. Draw a conclusion from the results of this experiment. Now this should be pretty straightforward, but you're going to have to be careful about that change and rise thing, and also that you're actually answering the aim. Okay, so here's your data. This is from the original context, and look very carefully what it's asking you to do. To investigate the effect of copper sulfate concentration, and this is the most important bit, on catalase activity. So it is not actually this. It's not the time taken for the paper disc to rise. So if you try and answer this by talking about the paper disc rising and not linking it to catalase activity, you have not answered the question. Now it is a pretty straightforward link. As the concentration of the copper sulfate is increasing, the time taken for the paper disc to rise is increasing, therefore, this is the most important thing, the catalase activity is decreasing. Okay, so you must link it to catalase activity for you to have answered the question. Here's our mark scheme. We have plenty of potential answers for quite a lot of different things. You'll notice they have underlined certain stuff. These are saying that this is an absolutely essential thing. Notice that we were talking about catalase here and not anything about the time for the disc to rise, as I was stating. And here's your 2 points, one for your labels and scale and one for your points labelled correct or joined up correctly. They were given other options than water bath. You could say incubator, you could say oven. Water bath is the one that I would expect. Okay, make sure you're happy with it. It's another one down.